Hey, so this is just going to be a quick video for you because I am at school right now doing professional development, so I don't have a ton of time. But hopefully this will make a little more sense to you. And if not, there are lots of like YouTube videos about equivalent resistance in series and parallel circuits that maybe watching a couple more of those on top of this might have it make a little bit more sense for you. But equivalent resistance is finding the total amount of resistance in a circuit. We have all these different devices in the circuit. We want to find what the resistance would be, just a single resistance, if we took into consideration the resistance of all the individual devices. And so you solve for it differently based on if it's a series or if it's a parallel circuit. A series circuit is pretty easy. So in series, all you need to do is add the resistance. So equivalent resistance is just adding all the individual resistances together. So for this particular circuit, I would do 15 plus 10 plus 6. And so that would give me then 31 ohms of resistance. So you just take all the individual resistances and add them up together. In a parallel circuit, they're added a little bit differently. So we take 1 over each individual resistance to find the total. And so I'll take 1 over 15 plus 1 over 10 plus 1 over 6 ohms. And now when I do that, so if I type in my calculator, 1 divided by 15 plus 1 divided by 10 plus 1 divided by 6, I get a decimal. So when I do all this, I get 0.333 repeating. So what I just found, this equation is set up to find 1 over what the equivalence is. So I found this in decimal form, fraction form, so now I need to turn it into a whole number. So with parallel circuits, there is one extra step. So after you divide 1 over all the resistance values, then we need to take then 1 over what that value is. So 1 over 0.333. So that's going to then give me a value of 3 as my resistance. You're asked up here to also find the total current using Ohm's law. So like once I found out that this is 31, I know that this is 10 volts. Ohm's law is our formula V equals IR. So I can plug in those values to solve for current. Now where this gets a little tricky is when we have complex circuits. So circuits that have both. And I'm going to actually skip this one. This is a complex circuit, but do one that's a little bit tougher that I had more questions on. And so I think working through this one, then you should be able to work through the other one just fine. Okay, so here I have a circuit that has devices that are in parallel as well as in series. And so on the back part of your note sheet, when you have a complex circuit, you want to add all devices in parallel first, find their equivalents, and then add them all in series. So this is by itself, so I'm not going to add anything in parallel. But I have these that are in parallel, and I have these that are in parallel. Now, I can't add them all in parallel together, 1 over 70, 1 over 70, 1 over 40, 1 over 40, 1 over 40, because they're not part of the same branch. So what I need to do is find the equivalence for this first, make that a number. Find the equivalence for this next, make that a number, and then they'll all be in series with each other, so then I can add them all in series. So 1 over 70 plus 1 over 70. When we do that here, we get 0.028. So I'm going to take 1 over that to turn that into a whole number. And so we get 35.7, so 35, 36 here. ohms. So I've done this section here. So this is about 35, 36 ohms here. Now I can do this section. So 1 over 40 plus 1 over 40 plus 1 over 40. And so when we do that, we get 1 over 0.75. So I need to take 1 over that then to find the whole number. So here I get about 13.3. So I found the equivalence for this section. I found the equivalence for this section. And I have this 100 here. So now I can add all these up together. So I can take the 100 plus the about 36 plus 13. So here I get, if I rounded this to 36, I'd get 149, but if I left it as with the decimals, I'd get about 148. But 100 ohms plus the 35.7 ohms plus the 13.3 ohms. So that'd give me the 148 ohms that I'd be looking for. So whenever you have a complex circuit, you need to add up everything in parallel first to make it an equivalent. So for this particular one here, you would add these up in parallel using 1 over 15 plus 1 over 10 to make that a number. And then you'll add them together in series, just one after the other. So hopefully that makes sense. That can help you solve a few more problems. And we can always get together before we test and get some more questions answered here for you. But again, there's lots of YouTube videos of this out too. So if you have a particular question or you want to see a few more problems, a quick YouTube search might also not be a bad idea for you. If you have any other individual questions, just let me know, okay? See you tomorrow.